Welcome everyone. We are now going to start the next part of the chapter of calorimetry. In this part, we will learn about the phase, change of phase, latent heat, and different other examples of latent heat. Now the question other appears that from where we will study. Again, I am suggesting you the same book of Selina Publications. You can start from there. The 11B chapter, that is our basic topic of studying. This is our basic topic today. So I hope all of you can now start opening your book. This part is called change of phase. Or state. The first question that appears when you start this, that what is this phase? What do you mean by phase? The answer is very simple. Just like the term phase refers to the physics of the term state. Just like on any object, you can observe any object, they can stay in either one state at a time. Just like either in solid state or in liquid state or in gaseous state. More states of matter are known, but that doesn't include in our syllabus. So we mainly focus on the solid, liquid and gaseous state. So states are basically three kinds: solid, liquid and gas, right? This thing is also known as the phase of matter. Okay, just like for example, if we take the common example of water, it can be in either any of the state. When it is in solid, we'll call its phase to be ice. In liquid, the normal name water, and in gas we call it water vapor. Okay, now that is the basic concept about phase and state. So phase basically means in which state the matter is at present. Now if we are looking for our main topic, that topic is change of phase. The topic change of phase means how the matter transforms from one state to the another. Just like how does a solid converts to liquid, or how does a liquid converts to gas, and vice versa. Even some direct conversions are there, like directly solid to gaseous or gaseous to solid. We name those things just like the conversion of solid, liquid and gas. They are interrelated. Solid to liquid is called melting. Liquid to gas, vaporization. Gas to back in liquid, this is called condensation. And liquid to solid, again called freezing. All of you know this. Now some direct conversions like solid to gas, what is it called? Sublimation. And gas to back to solid, This method is called solidification. So these things are already known to all of you about the change of phase. We will just discuss more important factors which you will learn in class 10. So first of all, we are starting with the first process, the conversion between solid to liquid and back liquid to solid. Solid to liquid, that is melting, and liquid to solid, that refers to freezing something. I hope all of you know this. If we just start with this topic of freezing and melting, we find out that these two processes are actually reverse to each other. Melting is just a reverse process of freezing. The method in which a solid changes into liquid is called melting. What is that definition? Total, I think you will disagree. Melting, the process of melting is basically the conversion of solid to liquid, but one more thing is there. At a constant temperature. That means when this conversion is happening, solid to liquid, this conversion is happening continuously. Okay? Now, one more thing is that the reverse process. The reverse process is basically known as freezing. Freezing is the conversion of liquid to solid at a constant temperature again. At a constant temperature again. So you can understand that when these conversions are happening, the temperature of the system remains constant. The temperature of the system remains constant. That means its value remains fixed. Let's observe. Just like try to understand the melting method. The melting method. Try to understand. I am dealing with an example. Just like I give you minus 10 degrees centigrade ice. The temperature of ice is minus 10 degree centigrade. Now you just keep on heating it. Its temperature rises. If you give heat, the temperature will rise basically. So minus 10, it will keep on minus 9, minus 8 degree, minus 7 degree, and so on. It will increase up to 0 degree centigrade. You know, at this temperature, the change of state happens. That means, what happens? I'm sorry, I'm talking about melting here. So the object melts that temperature. The object melts at that temperature. Means the ice becomes water. Now for this conversion, just like you started from minus 10, minus 9, minus 8, yes, you are giving heat, the temperature strictly keeps on rising. Now when it just reaches 10 degrees centigrade, its rise in temperature stops. Temperature rising stops until the whole block of ice temperature rising stops until whole amount of ice converts into water. That means if we are starting with 100 grams of ice and keep on heating it from minus 10 degree, its temperature keeps on rising and it becomes 0, then you also keep on heating it, but after reaching 0 degree, its temperature will not rise anymore. For the time being, the total ice of 100 grams is converting to water. After the 100 grams of ice is converted to water, its temperature will rise again. So until the process of melting is occurring, that process occurs at a constant temperature. Clear? Similarly, the reverse process is freezing. If you have 100 grams of water at 40 degrees centigrade, you keep on cooling, it keeps to cool down from 40 to 30, then 20, then it reaches 0 degrees centigrade. Now if you keep on cooling this, it will not go directly minus. No, not directly minus 1, 2, 3. No, it will stay at 0 degrees centigrade until the whole freezing happens at constant temperature. Means total 100 gram of water will first convert to ice, and further then its temperature will decrease. So all this melting, freezing, this process happens at a constant temperature, and during this change, when this phase change occurs, that value of temperature never varies. The temperature at which this thing happens, this melting occurs, that temperature is called melting point. Just like for water, the melting point is 0 degrees centigrade. For ice, the melting point is at 0 degrees centigrade, and the temperature at which this freezing occurs, that is called freezing point. Again, very simply, water freezes at 0 degrees centigrade. So 0 degrees centigrade is the freezing point of water. Basically, for all the substances, the melting point and the freezing point at same temperature and pressure will be always equal. So melting point temperature will be equals to freezing point temperature, of course, at constant pressure and temperature. At constant pressure and temperature. Not constant pressure. The question appears is now, after we understand this melting point and freezing point, why am I talking about this pressure kind of thing? Means what does this pressure affect? How does it affect the melting point? The answer is yes. The pressure of the atmosphere, or if you are doing in a laboratory, if you can control the value of pressure, then this melting point or this freezing point can be varied. Just like we can classify the whole scenario in two. First of all, we are discussing here, let me write the topic name, effect of pressure on melting point. Let me discuss one important thing very clearly. All of you might be thinking that when a solid changes into liquid, it's just the value of the volume will always increase. You always think that just like if solid converts to liquid, its volume will be increased by 10% or 20%, but it is not always true. That means that there are some exceptions. And most of the times, if you just melt down any substance, its volume increases. But there are some exceptions also present. Just like in case of ice. When an ice converts into water, when ice melts to water, is one of the main exceptions. The volume decreases. The volume always decreases. Okay, so remember these things, that not all the substances are same. So according to this, we can classify our substance into two parts. That objects or systems can be classified in two types. Objects which contracts on melting. What do you mean by this word contracts? Contracts means, you remember the volume expansion and the opposite is contraction, means its volume decreases, just like the example is for water. Water is the most common example known in these cases. In these cases, the melting point of the substance, the melting of this point of the substance like water decreases if we increase in pressure. Means, if I increase the pressure, the melting point will decrease. In case of water, means just like if the thing is happening at 1 atm, that is 1 atmospheric pressure, water is melting at 0 degree centigrade. If I just increase the double the pressure, it becomes 1 atm to 2 atm, the value of this melting point will decrease. Might be from 0 degree, it will melt at now minus 3 degree. So you can see that the melting point will decrease if I increase the pressure. And another kind of substance is objects which expands on melting. Most of the known objects actually expands, just like wax, lead, iron. These things actually expands if you melt it. In their case, the relation is just opposite. If you, so I read the example wax. Okay, if you increase the pressure, their melting point will increase. Okay, this means if you now, the previous case was that in case of water, when the melting point was decreasing, means water melts at 0 degree, you increase the pressure, it now melts at lower temperature, means its melting point decreased from 0 to minus 2, minus 3, depends on how much you are increasing the pressure. In case of the expanding substance like wax, lead, whose volume increases if we just melt it, in their cases If I just increase the pressure, the melting point increase. Means if the wax have a melting point at 20, if I increase the pressure, its melting point will shift to 21 degree or 22 degree or more. Depends on how much pressure you are just changing. So I hope all of you got this. This is the effect of pressure on melting point. So that's our complete discussion on the pressure. This is not the only way to change with melting point. There are other methods too. Another known method is adding impurities. If you add impurities in substance, air melting point in most of the cases decreases. It basically decreases. This thing is very much common in our cool phase. In the cool phase, we mix salt with water, and that decreases the melting point from 0 degree centigrade to minus 22 degree centigrade. So it depends on how much proportions you are mixing them. So this is another method of changing the melting point. We don't have much detailed discussion on this topic in your class, so this much we have to understand. And now the final thing is the plotting of the graph of melting or freezing, whatever you prefer. They have shared the same graph because they are the transitions between the same liquid and solid state. I am just going to plot a graph between the temperature and time. And here is in time. Just look at the graph. I am plotting this temperature in y-axis. I am basically plotting from minus 10 degree to plus 30 degree. And this is 0. Then it increases on positive side. Okay, that much is enough. So you can see I plotted from minus 10 to plus 12 degrees centigrade. Now suppose that you have taken an ice at minus 10 degrees centigrade. So in the time graph, I am plotting in seconds. 10 second, 20 second, 30 second, 40, 50, 60, and that's a rough estimate of time. Just like you have taken an ice at minus 10 degrees centigrade. So when the time is at 0, the temperature of the ice is minus 10. Now that is at the beginning, the temperature is minus 10. Now you keep on heating it. If you keep on heating the ice, what will happen? Its temperature will keep on rising like this. Might be very near to 30 seconds time, the temperature rises from minus 10 to minus 8642 and reaches 0 degree. Now at 0 degree what happens? At 0 degree the phase transition happens, means the ice will now convert to water. And as long as the ice is not converting completely into water, its temperature will remain straight constant at 0 degree. So for a long time this thing will stay at 0 degree centigrade. Just like it took 30 seconds for its complete melting process. After that it completely converts from ice to water. After the conversion from ice to water happens, now its temperature keeps on like this, like 2, 4, 6, 8, 10, 12, as long you are heating it. But during this time, the conversion time between ice to water, it stays constant at 0 degrees centigrade. In your book you can find it doesn't show the lower negative portion, it just plots from here to here. The same graph you can observe in your book in figures, that is a curve for freeze melting. Clear? So that's the thing. This graph basically shows the constant temperature nature of the melting or the freezing. Clear? If we just plot it reverse from -12 to 0 degree, then water converts to ice and goes negative further, that the same graph becomes freezing graph. If you are going -10 to +10, then it is melting graph. So this much we will study about the vaporizations. Now our next part begins. The next conversion is on vaporization. It's a conversion from liquid to gaseous state. This process is also known as boiling. The common name. We all know that. How can we define this thing? Now, its definition is very easy. Now, the change of liquid to gaseous state at constant temperature is known as basically boiling or vaporization. You can see at constant temperature, the same factor here, and the temperature at which this occurs, that means this constant temperature at which is this occurring, at which boiling occurs, is known as boiling point. Is known as the boiling point. In this part you will not find anything very tough, because all the things are very similar to the previous freezing section or melting section. The same things occurs. If I just again plot the graph, I will find the same thing, just like I am solving drawing the graph again for you. Again the graph is temperature versus time. Temperature versus time graph. Let's say that I'm not plotting the negative portions, I don't record, because I'm just converting from liquid to gaseous. So negative temperature for water. Let's start from 70 degree. So from 70 to 120 degrees centigrade I have plotted. And in case of time, in seconds time, 20 seconds, 40 seconds, starts from 0 second. Just like I give a water at 70, you keep on heating it, the temperature of the water rises, and just like at 80 seconds, for example, it can be varied. If you heat faster, it will occur fast. If you heat slowly, it will occur slow. Clear? It's just not a constant thing. It can vary anyway, like with time. So just like in my case, it reaches 100 degree at 80 degrees centigrade at 80 second time. Now at this 100 degree, it is still in water. Now what will happen? Now it will stay in the water at the constant 100 degrees centigrade until it is completely converting to gas. So for a long period of time, it will stay constantly at 100 degrees centigrade temperature until it completely becomes vapor. And that means it's gaseous state. After it happens, its temperature will rise again. Might be 110, 20, 30, 150 degrees centigrade, how much you keep on heating it. So this is how the graphical things work again here. Now, change in volume. In most of the cases, all liquids expands on boiling. Unlike there in case of melting, there are some solids which contracts, like the ice contracts in case of the melting. Here is no exceptions. All liquids expands when they are converted to liquid to gaseous states. I hope this is clear. Now, the question might strike your mind. All the good students might be thinking that, okay, previous section we found out that this melting point can be varied with pressure. Can this same thing happen for boiling point? The answer is yes, you have guessed it right. The boiling point can also be modified using pressure. And the formula is very simple. So let's study the effect of pressure on boiling point. The law of the effect of pressure on boiling point is very fixed. If you increase the pressure, the boiling point will increase. If you decrease the pressure, the boiling point will decrease. So it's very same. The boiling point increases with increase pressure. Clear? And decreases with decrease, the vice versa. That means at 1 atmospheric pressure, the water boils at 100 degree. If you just increase the atmospheric pressure, the boiling point will increase. And if you decrease the pressure, the boiling point will decrease. Means if you increase the atmospheric pressure, water might boil at 105 degrees centigrade. And if you decrease the pressure, it might boil at 95 degrees centigrade. All of you remember the requirement of pressure cooker in the hilly areas, and that completely comes to this topic. Why do we require pressure cookers? So, not going much in detail in that case. I hope all of you know about this. If you don't know, you can ask me later in the comment section or in privately inbox me. But that much with the change of phase. Now our next lecture will be on the latent heat. And yes, one more thing is that impurities can also be used in that cases. Again, impurities increases boiling point. If you add impurities, the boiling point will increase. That means you have water, you added salt with it, or you just added sand with it. So sand is not going to mix with it properly. Sands are not dissolving in it. So if you just add salt, sugar or salt, the boiling point will strictly increase. That from 100 degree it will become 104 or 110 degrees centigrade. Depends on what are you mixing with it. Clear? So that is the effect of impurities. So thank you everyone. Next video will be on latent heat. Keep on studying.